the first things on Unit 6. And on the top of your paper, everyone, whether you're here or not today, if you're absent, it is still going to be due on D2L on Monday, February the 16th by midnight or 12 a.m. Okay? So I wanted to make sure, please make sure you put your name on it right now. This is the due date. I wanted everybody to come in. I'm videoing it for those who are not here today. They are still responsible. This will be a lab. Do you see a lab grade? Now, the problem with this paper is that when you look at it, it looks pretty easy cheesy. And we're going to do some, look, coloring right here, right here, right here. The problem for me, I told everyone last semester in the beginning of the school year, number one, when it comes to colors, I expect us to use colors. If it says red, don't give me pink. That makes me mad. If it says blue, don't give me sky ocean blue. Give me Dickinson Gator blue. If it says red, give me Hitchcock Bulldog red. If it says orange, give me TC Sting orange. If it says yellow, give me the sun yellow. If it asks for green, don't give me olive green. Give me Santa Fe Indian green. I don't know how else to say that. I want it to be very straightforward. I shouldn't have to guess your color, okay? And the reason why is kind of like that argument, how do you know green is really green? Well, there's a scientific reason for that, and we're going to get into that later on, why green is green. That's because of its wavelength. That's why. Okay? We'll get scientific on that. So I need it to be the exact color, number one. Number two, when it asks you to do circles or to do squares or box it in, don't be lazy. If you do sloppy work, then you're going to get a sloppy grade. Let me say that. That way, I might let Cleo grade y'all's paper in that situation. So here we go. Let's go ahead and get started. This is called a transverse wave. Maybe we should go ahead and call this a transverse wave, which is a mechanical wave. Okay? This is a transverse wave, which is a mechanical wave. In our notes, we're going to have a little chart, like a little diagram, and we're going to say waves. And all waves are broken into two groups, mechanical or electromagnetic. Mechanical waves, there are two types. Depending on the way they look is how we judge them. If they go up and down like the ocean, it's called transverse. If it looks like a spring or a slinky, then it's called a longitudinal wave. Now, all waves, though, whether you're transverse or longitudinal, have different parts of it. For an example, this line right here that goes through the middle, or this line right here that goes through the middle, is what we call the equilibrium. Equilibrium. The equilibrium. The equilibrium is when the wave is at rest. When the wave is at rest, it's in equilibrium. Now, when the wave is not at rest and it's moving, it's going to go up, down, up, down, up, down. How high up or how far down from the equilibrium is what we call the amplitude. How high up or how far down is what we call the amplitude. Now let's pause for a moment. Let's imagine we go over to the beach today in Galveston. The water is going to go whoosh, whoosh, whoosh. But wait a minute. Next school year, in September, August, October, October-ish, when it's called, what do we call that around over here? If you live in the Gulf, we call that hurricane season. Let's pretend that come September, October, we're going to have, I don't want to put this out in the universe, but I'm just pretending. We're going to have a Category 5 hurricane that's going to hit in the Gulf. Legit. Just joking. JK. Okay? Wait a minute. If we go back to Galveston, we're standing on the seawall. The water's actually splashing over the seawall. That's about 12 feet tall waves. Look at this wave. Now imagine a 12-foot wave. How do 12-foot waves happen? They get energy. Where's the ocean getting its energy from? Where is that? Because when we go to the beach right now, look, it's so pretty outside. It goes, ksh, ksh. But a Category 5 hurricane, it's coming, boom, over the seawall. Those are 10, 12, 15-foot waves. Where would that wave get its energy from? Where do you think? The what? Say it again. 100% right. The wind. It gets it from the wind. Convection currents, the wind. The wind is how those waves come. So each wave gets energy, and it gets it from something. Whether, let's say now we have a tsunami, and that might be because of like plate tectonics under the ocean or something happened, and then you get this one giant big tsunami that hits, right? But if we're having a hurricane, because we live near hurricanes that happens, it's because the wind, the weather causes it. Now this wave, it got energy from something. And its energy is going to cause the amplitude to occur. What I'm trying to say is more energy, more amplitude. Less energy, less amplitude. Make sense? All righty, let's move forward. After that, we have what we call the wavelength. The wavelength is the length of one single wave, or what we call one cycle. A wavelength is going to be from middle to middle, from middle to middle. It can also be from crest to crest. It can also be from what we call trough to trough. Those are all wavelengths. So let me just to be a little bit easier for us. From middle to middle, from crest to crest, or from trough to trough. Those are all three examples of wavelength. And if you measured all three locations, they would all be the same. Okay? I just mentioned the top of the wave is called a crest. The bottom of the wave is called a trough. Like horses drink out of a water trough. They have to put their head down to drink out of a water trough. Okay? Oh, I'm missing. Oh, no, I didn't misspell it. I thought I misspelled it. Okay. Now let's go ahead and use our ruler, and we're going to use the centimeter side, and we're going to convert to meters. So for an example, amplitude from the middle rest part, or from the equilibrium up, or from the middle down, how big is the amplitude? Let's go ahead and measure that. I'm going to zoom in, double check it, but look at your zero. My wooden ruler, its zero is way over here. So I need to go ahead, measure that. And there we go. Looking at this, our papers for this first problem should be the same. After that, I've got 4 different worksheets that are out and about. So good luck trying to copy off somebody. Yeah, 4 different versions. So look, 0, 1.1 is what I got. I got 1.1. You might have got 1.2 on yours. I got 1.1 centimeters. Convert it to meters. Oh, King Henry drinks utterly delicious chocolate milk. If I'm at centi and I got to go to meters, I need to move the decimal places 2 places over. 2.011. For the lab paper, here's how I grade it. Because I have all of these pre-done, if I got 1.1, I will allow you to go over and under 1/10 of a millimeter. 1 millimeter over or under. That's how I'm gonna grade. So now I told you, I just recorded it. I'm gonna post it on D2L. Now you know to take your time. Wavelength, measure your wavelength. Double check me, but I'm gonna come over here. I'm gonna zoom in, like really zoom in so you can see. I'm gonna go from here to here, crest to crest. I mean, you can go trough to trough, but 3, this is where the student last class period called it 1 point something, 3.5, I'm good with 3.5. Convert it, 0.035. The next question, it's gonna ask you, hey, how many crests? 1, 2, 3, 4. How many troughs? 1, 2, 3, 4. The next question here, what's the velocity of a wave? That equation is on your formula chart. That's one of the next equations that we're gonna have to work on. So it says here, if this wave took 5 seconds to occur, and go ahead somewheres write this in, there is a total waves. What's my total amount of waves? Start at the beginning. From beginning, up, down, middle. 1. Middle, up, down, middle. 2. Let's do it again. Up, down, middle. 3. Do it again. Up, down, middle. There's a total of 4 waves, and it took 5 seconds to occur. My velocity is frequency times lambda. Lambda is actually the wavelength. And frequency, we already talked about when we talked about circles last semester. Remember when we talked about circles? 1 over period is frequency. And there's another way to calculate frequency. It's in your notes, our circle notes. What's the other way? No, 1 over period would be one way. So, what's the other way? Well, guess what? Last class period, no one remembered, which is A-okay. You need to go pull up your old notes and figure out, it has to do something with cycles in time or circles in time, which is the same thing over here. We have 4 cycles and the amount of time took 5 seconds. Give it to me. 1 over period equals frequency. That's the traditional equation for frequency. Just like to calculate period, which is capital T, is 1 over F. Good call. Good call.